Today we're doing section 10.3. This is for Algebra 1. And the topic is solving radical equations. So what that means is there's a square root already in the equation. So say you have the square root of x plus 3 equals 13. Or you have something like the cube root of x minus 6 equals 2. So you have a radical in the equation already. Before we've used radicals to solve equations, but we haven't had a radical in an equation. So let me start by showing you what to do on these two. Okay, so for this one, example 1, I'll just put example 1 right here. I need to get the square root alone. So I'm going to subtract the 3 from both sides. Hey, Minnie. My puppy. My puppies are next to me. Okay, so drop down the square root of x. This is 0 equals 10. Okay, no fighting, you two. Okay. That was Minnie touching my tablet. Hey, Minnie, stop it. Okay. Then get another colored pen out. Pause it if you need to. You're going to square both sides. The reason you're going to square both sides is because there's a 2 in the corner. Okay. Okay, so because there's a 2 in the corner is why you square both sides. And then this side you get x, and this side you get 100. And that's the end. Now there is a requirement for a full check on even radicals. Okay, even radicals is when the corner is even. So this right here, if there's an even number here, then you have to do a full check. So, and you know, in my class, we don't usually do checks. Okay, but we have to do a full check for these. So we do square root, we substitute in the 100, plus 3 equals 13. And this is because some of the time the math gives you the wrong answer. So it's not that you've done anything wrong, it's that there's an error in the process of the math. Okay. So this one worked, so this is okay, and then this is the final answer. Sometimes I'll put a double box reminding myself that I did check it. Okay, then here we have example 2, the cube root. Now, with odd radicals, no check is needed. So you just solve the problem, and as long as you didn't make any errors, then you get the problem right. Okay, in this one, the 6 is underneath, so I can't add 6 to both sides right now. I have to get rid of the cube root. So I'm going to cube the cube root on both sides, and that cancels out the cube root and the cube. Then you get x minus 6, and then you're going to have to work out the right. So that's 2 times 2 times 2, which is 8. X minus 6 plus 6 plus 6. So x equals 14. I don't have to check the answer, although I can, because it's an odd radical. Let's do another odd radical. Okay, so another odd radical, say I have the 5th root of x plus 4 equals 6. Now, this is not allowed what I'm about to write, so don't write this down. You can't do 5, 5, 5. Okay, you can only do one exponent of a 5 on each side. Okay, so this 4 is in the way. So I need to move this first so that I can get the radical alone, the 5th root alone. And then I raise each side to the 5th power. And then that will cancel out the radical. This is x equals, and that's 2 times 2 times 2 times 2 times 2. So that's 4, 4, 2, 8 times 4, which is 32. And that's the fifth root. So that's it. Okay, so let's get some that are more complicated. I have one more that I want to show you like this. Okay, we have quite a few examples today because there's so many different situations. 1 minus radical c equals -2. Okay, so let's get rid of the 1. I don't want the negative there in the front, so I'm going to divide by -1. That's radical c equals 3. And then how do you get rid of a radical? You raise it to the power that's in the corner. So this corner is a 2, so you put a 2 exponent, 1 on each side. And you can only put 1 on each side. This side cancels, and you get c. And this side you get 3 times 3, and that's 9. Okay, I kind of box it, but then was it an even or an odd radical? So if it's an even radical, then you must do a full check. So what you do is you start with the original problem, substitute in the number. It has to be the original problem. 1 minus, that's 3, equals -2. -2 equals -2. Okay, that's fine. That check works. And that's it. Let's see if I have another one. Oh, let's do one like this. This is example 5, but it's in the odd radical column. So that's why I'm putting it on the right side and not the left side. Okay, so I have the third root of 3x minus 6 equals the cube root of 5x plus 14. So I need to get rid of the cube root. So to get rid of the cube root, you're going to cube each side. You get 3x minus 6 equals 5x plus 14. And then this one has x's. There's more than one x. So we need to collect the x's. But how are we going to do that? They're on the opposite side. So that means you need to move. I like to move my x's to the left side. And then I like to move my numbers to the right side. So minus 5x minus 5x. The equal sign is here. -2x minus 6 equals 14. Add 6, add 6. -2x equals 20. Divide by -2. X equals -10. Do I need to check? Now I could have gotten it wrong just because I made an error. But do I actually need to check? And the answer is no, because it's an odd radical. So odd radical, which means there's an odd in the corner, no check is necessary. Now you can always check just if you want to check any math equation, but there's only 3 times that checking is necessary. One is even radicals, that's a full check. And then we have these other things called algebra fractions or rational equations. Has to be checked there. And then in logarithms. Those are 2 topics you'll learn in Algebra 2. Okay, so let me go to the next example. Example 6. Okay, I'm not able to do a live video today. So then I'm going to post this one. And then you guys can copy it down. And then you can do the homework. I'm probably faster when I don't do the live video, so you'll want to pause anytime you have a question. Okay, those all look good. Okay, I want a different one with some x's in it. Okay, so I want to show you this example. X equals the square root of x plus 6. Now I see my radical, and it's an even radical. There's a little 2 in the corner if there's no number in the corner. Okay, and the radical is alone. It's already on that side. So I'm going to raise this to the second power and raise this to the second power. So I get x to the second equals, those cancel, x plus 6. And then you pause here for a minute because we haven't seen one like this since last week, the week before actually. What do you do when you have an x squared and an x and a number? So when I see those three things, I think, okay, that's a quadratic. I could use quadratic formula, or I could use factoring, or I could use square roots and absolute values. Those are my basic methods. These two need an equal 0. So I'm going to start with that. I feel like this is for that. Square roots and absolute values is if you just have an x squared and a number. Okay, so I need a 0. So I am going to subtract this way. X squared minus x equals 6. Subtract 6. And then I only combine like terms. Now at this stage I can decide to use quadratic formula or I could use factoring. So I'm going to try a box and see if it works. So multiplies to be 6, subtracts to be 1. So 3 and 2. Okay, so this one factors, so I don't have to use quadratic formula. I always use quadratic formula if it doesn't factor or if I can't see how it factors. So 3 and 2, and then the big number is negative. I'm trying to get a negative one, so negative 3, and then a positive will give me negative 6. And then zero product property is x minus 3 equals 0, x plus 2 equals 0, plus 3, x equals 3, minus 2, x equals negative 2. So these are my preliminary answers. It is an even radical, so I need to do a full check on each because there's 2 answers. Sometimes both answers will work, sometimes neither answer will work, and usually one of each works. I'm going to rewrite the equation before I squared both sides. And let's check. So 3 equals radical 3 plus 6. And then I also, that's for x equals 3. And then for x equals negative 2, I would write negative 2 equals radical negative 2 plus 6. I'm substituting this in to the equation, and I'm substituting this into the equation. Okay, so let's see. So 3 equals radical 9. 3 does equal radical 9. Okay, so that worked. So x equals 3 does work. Negative 2 equals radical 4. Well, almost, but no. So I have to cross out the x equals negative 2 answer. And then this is the only answer. Okay. Let's try another one. Example 7. I think we're, see how much time do we have? Oh, only 13 minutes. Oh, I'm going way too fast on these. Let's look at another one. This is square root of a minus 4 plus 5 equals, let's say, 12. Okay, now I have to get this alone before I square both sides. Okay, you have to get the radical alone before you square both sides. So I'm going to subtract 5 from both sides. And then I'm going to square both sides because there's a 2 in the corner. A minus 4 equals 49. And then I'm going to solve for a. So how do you get a by itself? Add 4, add 4. A equals 53. Do I need to check? What kind of radical was it from the beginning? An even radical. So even radicals need full checks. So radical 53 minus 4 plus 5 equals 12. Radical 49 plus 5 equals 12. 7 plus 5 equals 12. Okay, that's true. So this is my answer for this one. I want to show you two different questions that look very similar. So I'm going to scroll down and show you both of these. Example 8, example 9. Okay, they're similar but different. So this one is 2 minus the square root of x plus 6 equals negative 6. And this one is 2 radical x plus 6. We'll put it doesn't really matter. Let's say minus 10 equals negative 6. So what I want to show you is what the difference is if there's a minus in between. This is a minus. And this one between is a times. Oops, let me put the square root back. So this one is a times. Okay, so for this one on the left, we're going to subtract 2 from both sides. Drop this down. Minus 6 minus 2 is minus 8. So this one you have to subtract the 2. This one, let's add the 10 to both sides. This one, how do you get rid of this, which is a times? You don't subtract it. What do you do with it? And the answer is divide it. So square root of x plus 6 equals 2. Okay. Now back to the left one. What do you do with the negative sign? Try to think of what you do with the negative sign. Okay, so you're going to divide by negative 1. X plus 6 equals 8. And now they both kind of look the same, right? So how do you get rid of a square root? And square roots are the most common radicals that you'll see in math. X plus 6 equals 64. Minus 6 minus 6. X equals 58. I do have to do full checks on these because they're even radicals. So you put the number back in and work it out. So I'm going to put check. 2 minus radical 64 equals negative 6. 2 minus 8 equals negative 6. Okay, that's true. So this is the answer for that one. And then for this one, how do I get rid of a square root? I square both sides. So I get x plus 6 equals 4, minus 6 minus 6, x equals negative 2. Let's do a check, full check, because it was an even radical. Two radical negative 2 plus 6, minus 10 equals negative 6. So you substitute it into the original. And you work it out. Most of the time, the answer is yes, but definitely sometimes the answer is going to be no. So this also works, especially when there's two answers. Okay. I want to give you one more reminder. So this is example 10. Is when things are solving by graphing. Now you're not going to have to graph to solve, but there's some examples in the book where they've already graphed them for you. So remember, if you're solving by graphing, okay, so say we had a graph like this, because the R's and the S's are the ones that are in this assignment. And then you have another graph. Maybe the graph's like this. What was the answer? What was the answer? Do you remember what the answer was? So the answer is where they meet. So you write down the coordinates of where they meet. Okay? So the coordinates of where they meet is the answer to the problem. Okay, so this is for numbers 23 through 26 on the homework. For this assignment, we are going to be doing problems from the book. This is DL5. Don't use Slater or Photo Math or something to get these answers. Actually do the work yourself, because if you're not doing the work yourself, you're not going to learn anything. Okay, so this is page 564, which I will also post a photo of for you. Okay, numbers, let's see, don't they also have cube roots? Okay, they do. Okay, so let's see. Okay, I like these. We'll do 3 through 19 odd. So don't do them all, only do the odd ones. Then you're going to do 23 through 26. Those are the graphing ones. And then, okay, I think you only need to do 2 of these. Let's have you do 28 and 30. Okay, and then I want to give you some cube roots. So the cube root problems are over here. I want to make sure the numbers don't get too big. Okay, I'm going to have you do 37 through 41. And I like 44. Okay, and then 2 more questions. 49. And 53. Actually, 49 and 50. We'll do 53 and then 54. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, there's quite a few questions, but our video is only 23 minutes long. So usually our video is like an hour. So you have an extra time to work on the homework as well. Here we go. So this is going to be worth 10 points for this homework assignment. And then as usual, 5 points for the notes. So upload them both and make sure you hit submit. Some of you are not hitting submit.